Jai Hind. Good morning to all of you, my dear students. Today I will discuss basic of thermodynamic concepts. This chapter comes under the thermodynamics. I, Dr. Sanjeev Kumar, Associate Professor, Mechanical Engineering Department, Faculty of Engineering and Technology, Site Meerut. Now, thermodynamics. Thermodynamics is derived from the Greek word thermi. Thermodynamics is derived from the Greek word thermi and dynamics. So thermi it means heat, dynamics it means motion. So what will be the directions of motions and what will be the how much amount of the heat is transferred from one medium to another medium? This all thing we will discuss under the thermodynamics subject of thermodynamics. Now this is the definition of thermodynamics. Thermodynamics is an axiomatic science which deals with the relations among heat. Here main thing is among heat, work and properties of systems which are in equilibrium. It describes a state and change in a state of physical systems, and thermodynamics is the science of the regularity governing processes of energy conversion. Thermodynamics is the science that deals with the interaction between energy and material systems. So here all things, what will the heat, work or properties of systems, all things are discussed, but system are in equilibrium condition. And thermodynamics is based on the three E's. At first, E, energy, entropy and equilibrium. I will discuss one by one from all of the things. Thermodynamics basically entails four laws. First law, second law, third law and zeroth law. Zeroth law deals with the thermal equilibrium and establishes a concept of temperature. Temperature I will discuss later. And first law throw light on the concept of internal energy. And second law indicates the limit of converting heat into work and introduce the principle of increase of entropy. And third law defines the absolute zero of entropy. Now, these are the applications of the thermodynamics. Suppose in the summer season, any persons which is live in the AC rooms, and when he go outside the AC rooms, he feel hot. Why? Because this is the temperature difference. In winter seasons, we shake hand from my friends, and I feel or he feels that our hand is hot or cold, because this is the temperature difference, and this temperature difference will comes under the subject of thermodynamics. And this the study of the transfer of the heat and also the how much work is done by the system and how much work done on the system, all things are studied in the thermodynamics, and its applications in broad areas. Here we wear all types of clothes because of the equilibrium, because we want to equilibrium of our bodies from our bodies. And here its uses in the air conditioning, aeroplane, refrigeration systems, power plant and car radiators, and a lot of things were uses of the thermodynamics. Now this is the thermodynamic system. What is the thermodynamic system? Thermodynamic system is a finite quantity of matter or a prescribed region of space. This is called the system. And boundary, what is the boundary? Boundary is the actual or hypothetical envelope. Enclosing the system is the boundary of the system. And next, surrounding physical space outside of the system is called boundary. And here I want to give a non-technical example, because you are technical students and you have a lot things from the outside of the league, so you can better understand. Suppose we have written a letter, okay, and the written letter, the letter is a system, and after that this letter put up inside the envelope. This envelope is the boundary, and the other side of the outside of the envelope is called the surrounding. We are inside the room. This is the system, and the wall, its wall is the boundary, and outside of this system, outside of the boundary, this is called surrounding. Okay. Now types of system here: closed system, open system, isolated system, and adiabatic system. Now closed system. If closed, inside of the closed system, no mass transfer. Closed system, only energy transfer, no mass transfer. Suppose we are inside the room and some persons lock the room, so I can only sort it or calling, and no go outside without any persons comes and came and open the lock. Okay, so we are in closed system, and here only for I sorted, my energy is going outside, or I communicate to go outside, but my body can't go outside of this. It means this is the indications of the we are in closed system. And here example, this system is the mass of gas or vapor contained in engine cylinder, the boundary of which is drawn by the cylinder walls and the cylinder head and piston crown. Here the boundary is continuous and no matter may enter or the leave. Here gas cylinder, here gas is inside of the cylinder, and we apply the pressure force on the piston, the gas will be contract, and after that we pull the gas pressurized, then the piston will go forward. And if the boundary of the system is impervious to the flow of matter, it is called a closed system. And next, this is the closed system with moving boundaries. Boundary may be moved, because here this is the best, here gas is inserted inside the cylinder, and here this is the boundary, and we burn the fuel and heated this container, then that gases will be, pressure will be increased, temperature will be increased, so this gas apply on the boundary and its boundary will increase. So this is the best example of the closed system with moving boundary. Now open system, it means door is open, I can go outside, or if I shouted to any persons or calling any persons, he will easy listen or easy give response. So inside of the open system, mass and energy flow in simple way. An open system, hence for this open system is one in which matter flow into or out of the system. Most of engineering systems are open. Now isolated system. Isolated system. An isolated system is that system which exchanges neither energy nor matter with any other systems or with environment. Here, isolated system. Suppose I am in this room, and here a soundproof. Make this room as a soundproof and lock the door. And here, if I sorted any persons or calling any persons, no any persons can hear my voice. So it means energy will inserted in this room, and mass is also. So here no mass, neither energy nor mass with any other system or with environment. This is called the isolated system. And here adiabatic system. An adiabatic system is one which is thermally insulated from its surrounding. This is the thermally insulated, and it can however exchange work with its surrounding. If does not, it become an isolated system. And thermal phase. What is the phase? Phase. A phase is a quantity of matter which is homogeneous throughout in chemical composition and physical structure. Homogeneous system here. One is homogeneous and second one is heterogeneous. What is the homogeneous system? A system which consists of a single phase is termed as homogeneous system. For example, mixture of air and water, vapor, and water plus nitric acid and octane plus heptane. And heterogeneous system, a system which consists of two or more phases is called a heterogeneous system. Suppose water plus steam and ice plus water and water plus oil. And approaches of studying thermodynamics. Thermodynamics have approaches, two types of approaches. At first, macroscopic approaches, and second one is microscopic. Macro, it means big or total. Microstructure, it means small. So macroscopic, this is also called classical thermodynamics. Inside of the classical thermodynamics, study large number of particles, it means molecules, that make up the substance in question, and does not require knowledge of the behavior of the individual molecules. Okay, now macroscopic, this is also called statistical thermodynamics, and here concerned within behavior of individual particles. In microscopic, we study only concerned within the behavior of individual, but here study of the large number of particles. Okay, here study average behavior of large groups of individual particles. Properties. Here two types of properties are found of any gases. At first, or extensive and intensive. Extensive, vary directly with the size of systems. Intensive, independent. Intensive, it means it's indicate independent of the size. Intensive properties are independent of the size of the system. Okay, here extensive properties, for example, volume, mass, total energy. And for intensive, temperature, pressure, or any types of color. Color is not depend on the size of the wall, size of the chair. No. Extensive property per unit mass is called intensive properties. For example, a specific volume. Here, volume per unit mass. Volume per unit mass. Extensive properties per unit mass. It means this is the intensive properties. Now, a state and equilibrium. Here, a state system that is not undergoing any change. It's called a state. All properties of system are known and not changing. If one property changes, then the state of the system changes. And thermodynamic equilibrium. At first, I will discuss equilibrium. What is the equilibrium? A state of balance. A state of balance, it means it may be mechanical balance, chemical balance, and chemical balance, mechanical balance, it means no pressure, no force will exert on the systems, and no any types of unbalance, will create by the external agencies. And here chemical equilibrium, it means forward reaction is equal to backward reactions, and proper combinations of the mixture to form a molecule. And here thermodynamic equilibrium, a system is in thermodynamic equilibrium if the temperature and pressure at all points are same. Here one thing is more, system is in thermal equilibrium if the temperature and pressure at all points are same. There should be no velocity gradient. Here no velocity gradient, and the chemical equilibrium is also necessary. System under temperature and pressure equilibrium but not under chemical equilibrium are sometimes said to be in metastable equilibrium condition. It is only under the thermodynamic equilibrium condition that the properties of systems can be fixed. A system will be in a state of thermodynamic equilibrium if the conditions for the following three types of equilibrium are satisfied: mechanical equilibrium, chemical equilibrium, and dynamic equilibrium. Thermal equilibrium, now here thermal equilibrium, mechanical equilibrium, and chemical equilibrium. Thermal equilibrium, it means equilibrium, it means same. Thermal, it means heat. The temperature of system does not change with time and has same value at all points of the system is called thermal equilibrium. And mechanical equilibrium, it means there are no unbalanced force within the system or between the surroundings. The pressure in the system is same at all points and does not change with respect to time. It's called mechanical equilibrium. And chemical equilibrium, it means no chemical reaction takes place in the system and the chemical composition, which is same throughout the system, does not vary with time. Time is important. Thermal equilibrium, temperature does not change with time. And mechanical equilibrium, here no unbalanced force within the system or between the surrounding. And chemical equilibrium, here no chemical reaction takes place in the system and the chemical composition, which is same throughout the system, does not vary with the time. It's called chemical equilibrium. Now total energy of system, here total energy is indicated by E. Total energy, it means maybe thermal energy, mechanical energy, kinetic energy, potential energy, electrical energy, magnetic energy, chemical energy, and nuclear energy. Every types of energy that can exist in a system. For system, sum of internal kinetic and potential energies. Here we can write here E is equal to U plus KE plus PE. E is the total energy of the system. E is the total energy of the system, and U internal energy, KE kinetic energy, PE potential energy. Kinetic energy half mv square, we know that, and potential energy mgh. And here system's internal energy is equal to sum of macroscopic energies. Here spring is attached with two bodies. This is the sensible and latent energy, and here the two molecules are connected with each other with the chemical energy, and here this is the energy is transferred by the bombardment of nucleons. This is the called nuclear energy. And now cycle. Cycle. Any process or series of process whose end states and identical is termed as a cycles. It means, suppose here where a start one point and end to the same point is called the cycle. Okay, point function. What is the point function and path function? Point function, when two properties locate at a point on the graph or coordinate axis, then those properties are called the point functions. For pressure, temperature, volume, we can show the graph. Here, suppose I have to draw a Otto cycles on pressure and volume diagram. Between the pressure and volume diagram, so here it means I can draw the graph of the Otto cycles in PV diagrams on coordinate axis here. So this is the pressure, temperature, volume. This is the point function, and this is the point function is an exact differential. And path functions, they are certain quantities which cannot located on a graph by a point, but they are given by the area also on that graph. It is called path function. This is work or heat. This is the example of the path functions. And here del q by del q from 1 to 2, we can write q2 minus q1, and it's shown as 1 q2 or q1 to 2. Similarly, for work done, W1 to 2. Heat and work are inexact differential, and here del is used for denote the inexact differential and D is used for denote the exact differential. So this is the point function. Point function, it means you can draw, you can show the properties of any materials on coordinate axis basis. So this is the point functions. And if any types of properties of systems, that's or size or area indicate or located on the graph, is called path function. Now zeroth law. First R.H. Flower in the year of 1931 give the concept of the zeroth law of thermodynamics. Inside of this inside of this law, if two systems are each equal in temperature, suppose here T1 temperature and suppose here T3 and here T2. Suppose here, if two systems are each equal in temperature to a third, they are equal in temperature to each other. Suppose here temperature T1 is the temperature of body 1, the temperature of body 1 is T1 and temperature of T2 here T3. So we connect of the body 1 and 2 with insulated chamber. All body are insulated chamber, and we connect both. We connect both 1 and 2 by the insulated pipe. That's the temperature of the body 1 and temperature of body 2 will be same. And similar fashions with connect of the body temperature 2 and body temperature 3 of the body 3, the temperature of the body 2 and body 3 will same. And if connect from 1 to 3, so this is the what will be the temperature of the body T1 1 or body 3, that may be in equilibrium. So here, if two systems are each equal in temperature, 1 and 2 temperature is equal, then this temperature will be equal to the body of the 3. Now process and path. When a system changes from one equilibrium state to another one, it's called process. Process may be isobaric, isothermal, isoporic, isentropic. Isobaric, pressure constant. Isothermal, temperature constant. Isentropic, entropy constant. Isentropic is also called reversal adiabatic process. And isoporic, volume constant. And path, this is the series of states which a system passes through during the process. Now here this is the compression process, here this is the initial point and this is the final point, and from path flow from the initial state 1 to final state 2, this path followed by, this is the called process path from 1 to 2. Here piston is moved, this is the bottom dead center and this is the top dead center. Here piston is moved from BDC to TDC, force applied on this, and here thus piston move from BDC 1 to 2. This process is called compression process. And quasi-equilibrium process. Quasi-equilibrium system remains practically in equilibrium at all times and easier to analyze. Equations of a state can apply. Work producing device deliver the most work consuming device consume the least amount of work. Inside of the quasi-static process, in quasi-static process, suppose we apply the load inferentially at during the interval of the time, and that the process will follow on that path. Quasi-static process is the reversible adiabatic process. If load is applied on that particular time, and suppose if I go, suppose this is the, for example, this is the state. Okay, if I put up one leg in this state, second this, third this, fourth this, and put the final destination, this is the quasi-static process. And suppose if I go on first here and second here, this is not a quasi-static. So, or suppose here one go or second or third and in downwards directions here on here and this position, this is not a quasi-static process. A quasi-static process, it means inferentially changeable on proceeding of that path, same path. Okay, thank you very much for listening carefully.